All right, y'all, welcome back. Today we're going to talk about topic 5, day 7. Okay, and this is going to be all about inverses of functions. Okay, so when you hear about inverse, all right, we want to think of kind of like the opposite. Now, it's not exactly like that, but it's going to be kind of similar to it. All right, so this very first thing, it says given f of x equals x plus 4, and the domain is 1, 2, 3, 4. Now, remember, the domain is the same as the x values. All right, the function can be written as, now let's say I wanted to write this with ordered pairs. The x value is 1, right? And if I plugged 1 into here, I would get 5. So 1 comma 5. The x value is 2, and if I plug 2 in, I would get 6. If the x value is 3, and I plug 3 in, I would get 7. And if the x value was 4, and I plugged it in, I would get 8. Okay, so another way to write that same function, f of x plus 4, is just like this, right? Because we're taking the x and we're adding 4 to it each time. All right, now here's where the inverse comes in. If we swap the coordinate positions, then we define the inverse of x. The inverse of x. Okay? And the way that we notate the inverse of x is with an exponent of -1. So this doesn't mean f to the negative first power. That means inverse. Okay, that means inverse. And if we did the inverse of x plus 4, right? Basically, all we want to do is switch the x's and the y's. Okay, that's all we need to do is switch those things. So the inverse would be something like x minus 4. That was x plus 4. The inverse would be x minus 4. And my new points would be just to flip these. So it would be 5 comma 1, 6 comma 2, 7 comma 3, and 8 comma 4. Okay, so the inverse is basically just flip it. So kind of like the opposite. Okay, now the same thing is also going to apply when we perform a function composition. Okay, which you talked about last class, or which we talked about last class in your video with Ms. Davenport. Okay, with inverse functions yields the same identity function. So if you take two things that are inverses and compose them, right? So if you take the inverse and put it into the original, so let's say you did the inverse here was x minus 4, right? So remember, we just substitute that in. And then let's say you took that x minus 4 and plugged it into f right here for x. So that would give you x plus 4, or excuse me, that would give you x minus 4, then a plus 4 on the outside. And if you put that together, right, the 4's cancel, you're left with just x. So this means they are inverses of each other. Okay? If you compose them, you put one inside of the other and you get x, that means they are inverses. The same thing would also apply right here. So let's say we did f inverse, but f of x is x plus 4, and then I took x plus 4 and plugged it into x right there, that would give me x plus 4 minus 4. And again, the same thing is going to happen. 4 minus 4 is 0, and I'm left with just x. Okay, so if you compose them, you put one inside of the other and you get x, then they are inverses. Okay, so the next thing, the domain of f of x equals the range of f inverse. So remember, domain is all the x's, range is all the y's. And we just did that right here. The domain of this one, 1, 2, 3, 4, the domain equaled the range of this one, 1, 2, 3, 4. Right? So the domain of the original is the same as the range of the inverse. Okay? And the same thing is also true. The range of f of x is the domain of the inverse. Okay, so again, you're just flip-flopping them. All right, so don't let the whole inverse thing confuse you. You are just flip-flopping them around. Okay, so functions with inverses are called 1, 2, 1 because each x is paired with one y. So like this 1 pairs with the 5. This goes with the 6. 3 with the 7. 4 with the 8. Notice the 1 isn't also going to the 6 or the 7 or the 8, right? It just goes with one number. So that means that it is 1 to 1. Okay, so 1, 2, 1. All right, so here's what we're going to do right now. We are going to see if these two functions are inverses of each other. Okay, and for us to do that, we're going to do this step. We're going to see if we put one inside of the other, if it equals x. If it equals x, then they are inverses. If it does not equal x, then they are not inverses. So what we are trying to figure out, if we did f of g of x, does that equal x? That's the question. All right. So if you remember from your video last class, we are going to take g of x is on the inside. So I'm going to take this right here, g of x, and I'm going to plug it in right there where I see g of x. Okay, so that would give me the f stays the same, and then I put this whole equation in, negative 1/3 x minus 4/3. Right, all I did was substitute. Now I'm going to take this part right here, and I'm going to plug it into the f equation because there's an f in front. So if I did that, it would give me 2, because there's a 2 in front, parentheses negative 1/3 x minus 4/3. And now we just need to simplify this and see if we can get it to be x. All right, so again, we would distribute. So that's negative 2/3 x. 2 times 4/3 would be minus 8/3. And there's nothing we can do with that, right? Because I can't change these to get them to cancel out, right? I'm trying to get x all by itself, but I couldn't do anything here. So these are not inverses of each other, okay, because they did not equal x when we put them together. All right, now let's see one where it actually works. I'm kind of giving you a heads up here. This one is going to work. So let's do the same thing. We're going to do f of g of x and see if that equals x. So once again, take g of x, take this thing, and plug it in where I see g of x. All right, so that would give me the f stayed the same. That would give me negative x minus 3 to the 5th power. Okay, and then I take this and plug it into the f equation now. So it's going to look a little bit ugly. So there's a minus sign. Then I plug all this in. So there's another minus sign. Then there's the 5th root of x minus 3 to the 5th power. And then there's still a plus 3 on the outside. Okay, now we got to simplify. All right. So these two negative signs become a plus right next to each other. The 5th root and the 5th power will cancel. And I'm just left with the x minus 3. And I still have that plus 3. So everything canceled, made it look pretty nice. So minus 3 plus 3 is 0. So I'm left with just x. So yes, these are inverses, because it came out to equal x. Okay, and if it equals x, then they are inverses. Hopefully this is making sense. Please feel free to pause it if you need to. All right, let's look at our second page. This, now we're going to look at it in graph form. Okay, we're going to look at it in graph form. So if the point AB lies on the original graph, then the point BA, because remember we just flipped them, lies on the graph of the inverse. So if AB is on one graph, BA is going to be on the inverse of that graph. Okay, the graph of the inverse of x is reflected across the line y equals x. So basically it's a diagonal line going right through the middle. Okay, so you see this line right here, that is the line y equals x. Kind of hard to see, but it's like a dashed line going right here. That's the line that it gets flipped over. So this is the original. If I were to flip it, that would give me the inverse. Okay, now we talked about the vertical line test to see if something is a function. Okay, now we're going to talk about the horizontal line test. So if a horizontal line in the plane intersects a function graph more than once, then the function has no inverse. So if you draw a horizontal line now that crosses more than once, then it doesn't have an inverse. So for example, if I drew horizontal lines on this one anywhere I wanted, it's only going to cross the graph one time. So therefore this one does have an inverse. All right, this one absolutely has an inverse, and we are going to find it. Okay, so I already have the graph here. Let's just pick out some points. All right, so I already picked some out. I have -1, -7. I have -6 or 0, -6, excuse me. Then I have 0, -8. Then I have 3, -5. 3, -5 is right there. And then I have 8, -4. 8, -4, did I count wrong? 1, 2, 3, nope, that's right, 8, -4. So there's my graph, right? The inverse, all I do is flip these. So the y's become the x's, -7, -6, -8, -5, -4, and the x's become the y's, -1, 0, 0, 3, and 8. So I just flipped it. And if we were to graph this new one, -7, -1 is right there. -6, 0, -8, 0, -5, 3, 1, 2, 3, -4, 8. -4, 8 is going to be right there. Now look, it has to be the same on both sides, right? So this point here, the -5, 3, has to be the exact same on the other side. So go over 2, and then 1, 2, 1, 2, 3, 1, 2, 3. Put the point there, and then just connect the dots. And if you look at these two graphs, I took the original, right, and flipped it over that line, so it landed right on top of that other one. So I can tell that those are inverses by the graph. Okay? All right. So pretty easy when it's graph, you just switch the x's and the y's. Okay, now we're going to find them algebraically. Okay, we're going to do two problems. So there's a few steps to do them algebraically. First, we're going to graph it and use the horizontal line test to see if it actually has an inverse. Right? You don't want to do all the work and then get to the end and be like, oh, snap, it didn't have an inverse. Okay? Replace f of x with y. All right, replace f of x with y. Swap the x and y. Then solve for y, and then put in the symbol for inverse. Okay? So here's the example we are going to do. It says determine if each function has an inverse. If so, find the inverse. All right, so here's what we want to do. So I'm going to help you out. I checked this. It has an inverse. Okay, I already graphed it, and I checked it out with the horizontal line test. So step 1, put y in for f of x. Keep everything else the same. 5 minus 2x over 3. Step 2, to find the inverse, I'm going to put a little 1 here. That was step 1. Right, step 1 was to put y in its place. All right. Now we want to switch the x's and the y's. So step 2, switch x and y. So x would go over here. 5 minus 2y over 3 would go over there. Right? I switched the x's and the y's. Step 3 is to solve for y, is to get y by itself. So in order to get y by itself, I first would have to multiply by 3. That way the 3's would cancel. And I get 3x equals 5 minus 2y. Then we would subtract the 5. 3x minus 5 equals negative 2y. And then I would divide both sides by negative 2. So 3x minus 5 over negative 2 equals y. That is my inverse, right? I switch the x's and y's and I solve for y. But the last step is to write it with the symbol for inverse so that we know that is the inverse that we found. So now take out the y and put in the symbol for inverse. So these two graphs right here, if I were to graph these, they would be reflections of each other over that line y equals x. Right? I would also just be able to switch their ordered pairs. Okay? Questions, confused, lost, something doesn't make sense. Hopefully you got it. Hopefully not. If you have questions, please let me know. Okay, I'll be more than happy to help you. All right, you guys have your assignment on Delta Math. But again, please let us know if you have questions. Thank you.